Good morning, and I hope you enjoyed the CloudStack conference so far. So I just arrived this morning, so I have a good experience of doing the first two sessions that I have been able to see. But what do I mean? And you probably not see, so this is the LinuxONE. So there's a nice picture, at least on my screen here. But what we talk about today is a little bit different than what I heard before. We talked about where can CloudStack run on. So it's less about capabilities of CloudStack, but more how could you leverage another hardware platform to get more out of CloudStack and get more capabilities. To start with that, I'm just starting to introduce a little bit what means LinuxONE, because that's just, what does it mean? This year we as IBM more or less have two anniversaries that we celebrate. 25 years ago, IBM, a few brave guys in the Böblingen lab brought Linux to the mainframe. That was 25 years ago. Since then, we had a good success from integration into the open source community, being in all of the Linux distributions. And as well, that's the second part. 10 years ago, we decided we are so in love with Linux, we want to make a hardware that really empowers Linux at its best. From its core, brings all of the knowledge and learning that IBM has on the mainframe for years, but dedicated and specialized for Linux. That's what we called LinuxONE, and that box is now 10 years old, and we've celebrated this year the 5th generation of it. And that's what you see here. So this is how it started as a big box, and it went all the way down to single rack with all of its beauty. What you see as well, we added a lot of capabilities, from secure execution capabilities in it up to quantum safe 2022. And all of those are really strong hardware capabilities that allow to run software more efficiently and to bring the benefits of a software like CloudStack with the benefits of a hardware that provides sustainability, security, performance at its core. Bringing those two together is a benefit for everybody who's using and managing it. As this is a different hardware, but it's important we have a huge ecosystem. So this is really about, we enable the open source system. That's the same what we're doing while we're working with the CloudStack team, and did this with the CloudStack team, is we have a huge ecosystem of software applications, open source environments that run on the 390 architecture where LinuxONE is based on. So this is not x86 hardware, this is S390 architecture, but in the end, a lot of people say Linux is Linux. There are some details, but it is really easy to get open source packages as well transported, and we have a huge team that helps getting all of this done, and you see at least a part of that ecosystem here. And what you probably have noticed there, on my picture, CloudStack is not here, but that's why I'm talking here. And that's why we think I will talk a little bit why we think this is really the most secure and most performant hardware to run Linux on, especially if we want as well go into AI. Just a few core concepts here to say. So one LinuxONE box can go up to 208 cores. A core in this case is not directly compared, can be compared with a core on x86. It's, in this case, more powerful. You can add more virtualization on it. And it goes up to 64 terabyte of memory that can be used on the box. The other part of what's special on a LinuxONE box is you have the ability to partition it based on your needs. You can separate the box into 85 separate hosts, which are separate from each other. You can share resources, you can dedicate resources, you can really mix and match what you want to do with the hardware, and by that, using the hardware in a more efficient and a more not accurate, but you can put more in a shorter dense on the system than what you can do on x86 hardware. And that's elements that we learned and where we optimized the operating system for a long time and the hardware for a long time. And this is what you all see here combined on one chart. Now, what I want to talk about today is I will not go deeply into the weeds, but what I want to give you at least a glimpse of what you can think of, what can be a benefit for you using that hardware or thinking about it in that direction. And this all goes from end-to-end security with privacy over how could such a box as well help you reduce costs in your operating from an energy consumption perspective, or how we could use it as well to build AI into your decision making as well from an application programmer perspective and the runtime perspective. Now, starting with security, I don't want to scare you away, but security should be in everybody's thought when he's doing IT. There's, I think over the last year, there's probably not one week where not somebody, at least in Germany, is talking about it, and that a company needed to pay ransom because their data had been encrypted by somebody who get into it, but that's only one part. There are many. So with hardware that helps you accelerate encryption or have special elements on the hardware that allows you as well going to a higher level on encryption, you can bring different levels of security to your applications, to your management environment, and by that protecting your values and be future safe as well. And if talking about this one, for me, the important part here to show is, as well, we have as well software that helps you managing it, key management software and all of this. But even more to show, we have hardware security modules that can run in the box that you can use for cryptographic operations that go up to what's called here FIPS level 4. FIPS level 4 means if somebody goes into your data center and takes out the card wipes itself. So that means all of the secrets will be protected. It's usually you have levels like level 3 is the highest one that you get usually in the cloud environment, where the card notifies that somebody's trying to manipulate the data, steal the data. Level 4 goes one level above. It protects the data automatically. And that's been tested a lot, tested in regards to going up to 40, 50 grads Celsius, heat, minus 40 degrees, all of those tests to check that nothing can be leaked out of the card, and this is what you can get here. And as well, what's mentioned here, quantum safe algorithms which are available with the hardware. So they're not in software, they're in hardware, so that means they're faster, can give you all of those elements, and you can use that for signing algorithms, you can use it for encryption algorithms, and this is all available automatically with all of the accelerators that are as well on the box. So if you take what really is the essence of LinuxONE, it is taking away workload from the core processor and putting it into accelerators. There are tons of accelerators, extra chips on the box that are purpose-driven for security, for data access, for sorting. There are multiple, a ton of processors added to this box to make elements faster, to let you run more on the hardware while those special processors are doing their job and being more efficient and getting all of that information back. Yeah, and this leads to those numbers. So definitely with security, you're not seeing performance degradations in that direction. And I'm not sure who of you is familiar with quantum safety and the whole paradigm behind it, but it's always the harvest now, decrypt later point. So we need to think now and how to protect the data that we generate today that potentially need to live for 10 years, 15 years on backups, on storage devices. If somebody just collects them and we are not able to detect that we still have them protected by the strengthening of the keys, because quantum computing is growing fast and it will definitely be, I would say, on the shorter range of the predictions when they will really be able to crack higher level or 2K, 4K, 8K key length. So I heard this before, not in this talk, but over here. When we talk something about it, it's good, but if customers say something, it's even better. In this case, I have two examples here. One is a bank that moved away, that wanted to build up a complete digital transaction system, and they used LinuxONE as the hardware, and by that they reduced the number of transaction times, and even as they grew, they did not run out of capacity. So that's really showing what we can do here with the hardware. The second one is Phoenix Systems. Phoenix Systems is like a cloud provider inside of Switzerland, having there a lot of presence within Switzerland as well. Switzerland has some data protection rules about banking data not leaving the country, and they decided, I think 5-6 years ago, to provide something what they call protected environments. That's really using secure execution, trusted execution environments that are being provided from LinuxONE, and using those to protect, isolate the workload that their customers are running on the platform, really by confidential computing standards. So that's really meaning the administrator of the box is not able to get into the workload, but he can manage it. And by that, we protect, with the hardware and the software together, the assets of the customers and giving more trust in those areas. Going short over optimization from a cost perspective, I said already, we have a lot of accelerators in the box. The big part is on a LinuxONE environment, you can run workload up to 80% CPU load. That's where the box has been optimized for. That had been a history of 40, 50 years of hardware and software working together to really get the box into a mode where it can run at 80% without having performance degradations. And this is what you see here as well with LinuxONE, that as we are all growing from an IT perspective, IT is getting more and more important. Even if I not include artificial intelligence and everything that's going on with AI, there is more and more IT that's needed to do all of the digitalization of companies, to get into what the younger people here are more used to. I'm as well used to. I'm more or less, my wife would say, I'm married with my cell phone. But really using everything with your cell phone. You want to have it available directly. And for all of this, we need IT. We need IT either as applications, as application programs, or as well somewhere the hardware needs to sit. And the hardware sits either in a cloud or in a private cloud. But in the end, at all of those places, it is growing. And with all of this growing, we are as well growing on this number. So 460 terawatt hours of energy had been consumed in 2022 just by IT data centers. And 20% of the costs of the energy costs of a company are usually coming from their IT infrastructure. Now, if you have a way of consolidating current hardware into a more dense hardware, you first of all reduce the number of power that you generate or consume by box. And the second part is you reduce floor space. Floor space means you need less cooling. So there are side effects on all of those elements, which are as well part of the overall costs, which you really can do with LinuxONE here to reduce the space. And we have good examples of customers. One customer that was on the decision point of buying or building a new data center because of their workload growth. And they made really the decision to move over to LinuxONE. And with that decision, they did not need to invest into building a new data center. They could just move over the workload to new boxes, and by that reduce floor space, bring additional boxes in, and had therefore a good combination of all of those. Now, one part, at least what you see down here, where a lot of my colleagues are really proud of, is that, I need to count it, it's 1, 2, 3, 4, 5, 6, so 6 nines. The availability of the hardware is 6 nines, 99.99999. That's a lot. So this is something really we're really proud of, with all of the elements in the hardware that went into to make that possible, to have spare CPUs available that automatically kick in if a CPU is dying, have all of those from a chip design as well included, which will help you on the cost reduction at the end. And one example here is another customer that really did a consolidation from Oracle. And you see here the ratio is 15 to 1. That's, in this case, the ratio that this customer could generate. So a 15 to 1 ratio from x86 hardware to LinuxONE. And that, depending on how many workload you move over, this is really giving you a lot of reduction of existing hardware that you need to manage, need to power, need to maintain. Going on. What we did 2022 was, with LinuxONE 4, we added the first AI chip that has been really included in the hardware. So that means we have an AI chip for acceleration on the hardware that is available for every CPU on the box to automatically, move out AI-specific workload that are necessary, in this case for, losing the English word, but it's necessary for really doing the decision at the point of a transaction. So if you want to have in a transaction the ability to say if this is fraud or not, you don't want to go out to another server where the GPUs are. This here really is the hardware allows us here to really, in the transaction, within the short time frame after transaction, make the decision if it's fraud or not. And this is for not only for a fraud case, but for other elements where we really want to have that decision at the point of the transaction faster and reliable. That's what we added here. We improved this on the LinuxONE 5, and we added as well. I'm just going over this. We added as well an extra accelerator card, as all of this, the large language models, the small language models, and generic AI is growing at scale. I'm not sure what really term we could use here, but the speed that is really in the AI currently, with the models, with the features of the models, with the number of features that they use in a model, is impressive. And we added here an accelerator card that helps as well, getting all of those included in the box and making it available with your regular workload and using it in this perspective. In this in this way. So one example here from that we worked on is really, in this case, is image recognition for medical and healthcare part. So we're really using the hardware and making this as a solution. For your reference, I just mentioned already anti-money laundering, but there are more use cases here that can be done with the built-in acceleration elements on the hardware to make that possible. Now, so far to what is LinuxONE. So now why I'm here. So I'm not here just to say that LinuxONE is a great hardware, but we did something last year. So what we did last year was we have an ecosystem team that's looking at open source capabilities and open source frameworks that we want to support to run on the mainframe or on LinuxONE. And last year, November 2024, that ecosystem team, quote unquote, ported, but at least compiled CloudStack with some small modifications on LinuxONE and made it working. Published a blog post. We thought it's good, so we continued to working with the community and added it now really into the latest release. It was 2025, I think, a few months ago. And the part that I wanted to show now is as well how this looks like. So how is it different? So do you feel anything about that it's different? So how does the architecture look like? And what I have a small demo here to show is what you really see here is we have CloudStack as the management plane. Oh, okay. CloudStack as the management plane, and we have here really the diverse or hybrid cloud environment. So we have x86 nodes, but we have as well LinuxONE as a host in that environment. And let's see if I made my donation to the gods of live demos. So yeah, this is, it's always the same. It worked 5 minutes ago. Now I know why. I had so thick fingers. So this is a regular, this is a regular installation of CloudStack. We have not done anything, any modifications on this. So I think you found yourself familiar with it. So what we have here is really, if I go down here, where this is infrastructure, management server. So the management server in this case is running on another virtualization system that we have, but you see here it's running on Red Hat, and it should be somewhere saying it's 6. Here you see the kernel version is x86 64. So that's the management part. So we came from the scenario we want to add LinuxONE with a KVM that's running in a what we call logical partition and add it to an existing CloudStack environment. And that's what you see here. The CloudStack environment is available. We have the management environment on x86. But what do we have as the host? In this case, we only have one host, so not the 200 hosts sample that was here before. So we have one host, and you see it's a KVM one, but what you as well see here, the architecture is S390X. So this is a host that's running on a different architecture. But in the end, if I look at it from a CloudStack perspective, it is managed the same, it represents the same. I can see the CPU, the memory usage. I see which Linux is running here, so that's Red Hat 9.6 KVM. But as well, I see that it is 390 from the architecture perspective. Now, how would it feel like when I really want to work with it? So I have images. I have images, templates in the environment. So you see here, I have images for S390X and I have images for x86. If you look at integrations like, or providers like Terraform, HashiCorp with Terraform, HashiCorp with Packer, they provide already ways of dealing with base images and using Ansible within Packer to really orchestrate and install software, modify software, get all of this automated. So in this case, as soon as I have a base image from a Linux distribution that provides me or runs on that environment, I can start and just have the same application automatically deployed on both sides, and I can then decide what do I want to deploy where, depending on my business needs. So do I need more security? Do I need certain hardware acceleration? Or no? So I can make the decision at the point of deployment based on my business needs and my requirements. So this is what you see here, and now, of course, I will as well, if I go into the system and say I want to create one, so I just use, in this case, the defaults, as I have, in this case, one in, I will use a medium version, give it at least some storage, and give it a name, and then it just, yes, didn't clean up well enough, so I created Milan 2. So in this case, you see this is the general process. It just integrated just a different hardware that completely integrates seamlessly into the patterns that you can use and you're currently using with CloudStack. So no difference on that part, and we are just using those capabilities as CloudStack gives us with the KVM that we provide on our side. And with that, I thank you for listening. If there are questions, I still have some minutes.